Hello everyone. Today we are going to solve the practice set 5.2 from the lesson GCD and LCM. GCD stands for greatest common divisor. Here we make the list of divisors and among those divisors we have to choose the greatest one. Let us see the first question. Find the GCD of the following numbers. The first one is 36 and 48. Firstly, we are going to solve it by divisor method. You can choose any one, either divisor or factorization. So here we made the list of divisors of number 36 and 48. And in those divisors, the commons are 1, 2, 3, 4, 6 and 12. And among these, 12 is the greatest one. Hence, the greatest common divisor is 12. And the GCD of numbers 36 and 48 is 12. Now here the divisors are means that 36 and 48 can be easily divided by these numbers, or 36 and 48 are present in the table of 2, 3, 4, 6 and so on. Now the next method is prime factorization method. Here we make the prime factors of numbers 36 and 48. The 36 can be factorized as 2 ones are 2, 2 8s are 16, 18 2s are 36, then 2 9s are 18, then 9 can be divided by 3 prime number, that is 3 3s are 9, and then 3 1s are 3. Now here in 48, the 48 can be divided by 2, 2 2s are 4, 2 4s are 8, then 2 1s are 2, 2 2s are 4, then 2 6s are 12, then 2 3s are 6, and then 3 3s are 3 1s are 3. Here we made the factors of number 36 and 48. Now we will write it in horizontal manner. So here we written the factors horizontally. Among those we have to choose the common factors, and the common prime factors of 36 and 48 are 2, 2, 3. And now among these common, GCD of two numbers, GCD of 36 and 48 is multiplication or the product of common factors. So 2 multiplied by 2 multiplied by 3 is equal to 12. Hence GCD of 36 and 48 is 12. Now the second question, second example, 31 and 2. Already 31 and 2 are the prime numbers, so they will have only 1 as their common factor. Hence the GCD of 31 and 2 will be the 1. Or you can make by divisor method by listing their divisors. So in that short list also we will find the 1 as a common divisor and the greatest one. So the GCD of these two prime numbers, that is 31 and 2, is 1. Now the third example, 65 and 13. Here we are going to use divisor method. The divisor of number 65 equals to 1, 5, 13 and 65. And the divisor of number 13 is 1, 13. 13 is also the prime number. So the greatest common divisor, as we made the common of them, and the greatest one is 13. So GCD of number 65 and 30 is 13. Now we can also use the another method, prime factorization method. In that we have to make the factors of 65 and 13. The 65 can be divided by the small prime number, that is 5. So 5 1s are 5, 5 3s are 15, and then 13 1s are 13. And the 13's factors are 13 1s are 13, that is only 13. So here we can make the common factor as 13 and the greatest one also. Hence the GCD of 65 and 13 is equal to 13. Now the fourth one example is 108 and 132. Here we will solve it by prime factorization method. So factors of 132, they are 2 6 are 12, and then again 1 remains, 2 6 are 12, then 33 2s are 66, then by 3 3 1s are 3, 3 1s are 3, and 11 1s are 11. Now for 108 we will start dividing it by 2. 2 5s are 10, 2 4s are 8, then 2 2s are 4, 1 remains, 2 7s are 14, then 3 9s are 27, then 3 3s are 9, and 3 1s are 3. So we will make the horizontally arrangement of these factors. So 132 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 11, and 108 is equal to 2 into 2 into 3 into 3 into 3. As we make the common factors, that is 2 comma 2 comma 3, and the GCD of 108 and 132 is equal to product of common factors, which is equal to 2 multiplied by 2 multiplied by 3. 2 2s are 4, 4 3s are 12. So greatest common divisor of 132 and 108 is 12. Now this one is the fifth one example. By mistake and fourth one is typed there. The example is 30, 24, 48, and we have to find its GCD. So here the divisor method is used. Make the list of common divisors of these numbers, then find out the greatest one. As we see, among these numbers 30, 24 and 48, the common divisors are 1, 2, 3 and 6, and the greatest one is 6. Therefore GCD of numbers 30, 24, 48 is 6. We can also use here another method by using prime factorization. So 30, 24 and 48, their factors are made here. 30 as 15 2s are 30, then 3 5s are 15, then 5 1s are 5. For 24, 12 2s are 24, 2 6 are 12, 2 3s are 6, and 3 1s are 3. For 48, 24 2s are 48, then 2 multiplied by 12 is 24, then 2 6 are 12, 2 3s are 6, and 3 1s are 3. Now we will write it horizontally, factors of 30, 24 and 48. So after writing the factors, the common factors are 2 and 3, and product of them is 6. So GCD of 30, 24 and 48 are or is 6. 2 multiplied by 3 is equal to 6. Now here question number 2 is of word problem. The problem is the length and the breadth of a room are 15 meters and 9 meters respectively. What is the maximum length of each tile to be laid in square tiles in this room? Means the room is of dimension 15 meter length and 9 meter breadth. In that room we have to fix the tile, and its length we have to decide here. So here the word maximum is used. Whenever the maximum word is there, we have to calculate the GCD. So for the lengths, that is 15 and 9, we will calculate its GCD. So we will make out the first factors. 15 is equal to 3 multiplied by 5, and 9 is equal to 3 3s are 9. So among those 3 is the common. So the GCD of 15 and 9 is 3. Hence, the maximum length of each tile will be 3 meter. A square tile should be of 3 meter length, and these kinds of tiles can be fixed in this room. Question number 3 is, a shopkeeper has 2 rolls of cloth of length 90 meter and 120 meter. He wants to cut both of the rolls into pieces of equal maximum length. What can be the maximum length of each piece? So here also the word maximum is used, and hence we will calculate the GCD of 90 and 120. So the factors of 90 are, 90 can be divided by 2, 2 4s are 8, then 1 remains, 2 5s are 10, then 45 can be divided by 3, 15 3s are 45, then 3 5s are 15, and then 5 1s are 5. Then 120 can be divided by 2, 2 6s are 12, and then 0 as it is, then 2 3s are 6, then 0, then 15 2s are 30, then 3 5s are 15, and 5 1s are 5. So here we have made the factors. Now let us find out the common among them. The common factors are 2, 3 and 5. Hence product of them, that is 2 multiplied by 3 multiplied by 5. 2 3s are 6, 6 5s are 30. So 30 is the product. Hence the GCD of 90 and 120 is 30. So the maximum length of each piece of that cloth will be of 30 meter. Hence for both the rolls he can make 30 meter length pieces of the cloth. Question number 4. A garland seller has 48 red and 60 white roses. He wants to make separate garland of both types of flowers. If the number of flowers in each garland is same, then what is the maximum number of flowers in each garland? Now here also the word maximum is used. So for the word maximum we will calculate the GCD of 48 and 60. Now by using prime factorization method we will make the factors of 48 and 60. Then we will find out the common among them. The factors of 60 are 2 into 2 into 3 into 5, and the factors of 48 are 2 into 2 into 2 into 2 and 3. So the common prime factors of 60 and 48 are 2, 2, 3, and their multiplication, that is 2 2s are 4, 4 3s are 12. Multiplication is 12. Hence the GCD of 60 and 48 is 12. The maximum number of flowers in each garland will be 12. Hence the seller can make 4 garlands of red roses and 5 garlands of white roses. I hope you understood the solution of this practice set. Please subscribe the channel for more practice set.